Adam Montel offered to be Jabber scribe.
If the Jabber is working. For at least for me, I had one issue that was I have jabber.org account and that disappeared. Oh,
Yeah.
okay.
Joey, that's one.
You should start in half? Yeah. All right, so it's 1 minute past, so we can start. So this is Ipsecme working group, and here's the notepad. You probably know that well already. And so we have blue sheets that they're calling around. They put your name there, or until if you don't, then we end up in closet again. We have been there a couple of times. And then we need note takers. And I think Paul looks like volunteering. Yes. Anybody else? Okay. All right. Paul will do it to take notes, and then chapter scribe.
Thank you, Adam.
Okay. Adam will take that. Okay. Here's the agenda. So we have a very short, summary of what the current working group drafts are, with what it's already, and then we have 2 presentations about the working group drafts that are still in process, and then we have some other issues, some other presentations about the PKCS 1.5, and then we have the main stuff that is a quantum resistance, which is things that needs still our work, and then there's a couple of other presentations in the compact representation of 5x2 payloads and the encapsulation ESP in UDP for load balancing. And then there's one thing that is not really our agenda or actually in our charter. It's the GDOI update or some small update. It's a document that was originally made in Ipsecme, but Ipsecme is closed, so that's why they were, and it's related to Ipsecme, but it's related to Ipsecme version 1, so we will see what's going to go on with that one. But they wanted to present, and if we have time, we will do that. So I think anybody has any comments about or changes for the agenda? All right, let's go forward then. So we have two drafts that are now already in the RFC editor queue. I think both of them are actually out 48 now. Yeah. And if it would actually be 48 hours, then it will be out soon, but usually it's more like out 48 days, so it might take some time. Oh, you have already proved already. Okay, so
for DDoS, right?
For DDoS, yeah.
Oh, great.
Okay,
thank you.
So they should be out. They already have RFC numbers, which I didn't list here because they are not yet out officially, but yes. So they should be coming out very soon. And as our charter process, we say that yes, we are going to get a couple of those out before the next IETF. And we were supposed to get the 4 out. We only get 2, but I think that's still quite good. Okay, the 2 of the other documents, algorithm updates, or the mandate to implement algorithm updates, are both, I think, ready to be submitted to ISG. We have to do the working group last call for the 7.3.1 piece first to be able to put it in ISG, and I think it actually might be worth of waiting, or actually we could do the the IETF last call for the first one separately, but I think for the telechat we want to put them in the same telechat because they are mostly the same and they have the same questions. it actually might be easier to explain why we have a different, things in IPsec and IKE if they come at the same time.
Right. So I plan to put the 7321 up for working group last call after this meeting. Are there any concerns with moving it forward with last call? Okay.
Yeah, I think we still have the one issue is this the NIST curves for mod B that we might want to discuss, but that's something that we can discuss during the last call.
Yep.
Okay, so then we have the other working group items. We have already adopted the TCP and CAPS and EDDSA as a working group items, and then we have the split DNS and implicit IV that are in the charter that are still waiting to be adopted. And most of these are waiting for, the queue to, empty first. We want to, get some documents out before we take more in, and it's also for us, the chairs, to be, check them out and process them forward. So they should be, now when we have getting for things out from the other end, we can actually take more stuff from the other end. And then they have a quantum resistance that still needs actual work. Okay, so then we come to this is the other items. I don't think we will actually be, this is what we have going to have presentations about, and then we are going to be having the first presentation, which is going to be Tommy about the split DNS and configuration for IKE version 2.
Okay, version 1.
Yeah. No.
Hello, I'm Tommy. So these will be pretty quick. I split into 2 decks because they're 2 drafts, but they should be fast. All right, so the first one is split DNS. Next slide. Yeah. All right, so we did get a round of review since last time. We incorporated the comments, and so what is new in this version? So first, we did clarify some of the stuff around DNSSEC. Paul switched it over to wire format for presentation format. I believe that is what everyone had agreed on, so hopefully that's good with everyone. We also added some explanation of the way that the DNS keys interact with the domain list. So we gave some specific examples that if you have multiple split DNS domains that are applying for your config, you in the configuration payload for the response, you put the DNSSEC items after the domains that they correspond with in order to show their association. That seemed the simplest way to get it clarified. And then we just had some other textual changes, so that's it. Next. Right, so I guess as you just explained, trying to get things pipelined through, so hopefully this will be going out for working group adoption soon. And again, if you want to try this out, we've already done some interop between our implementations, but we'd like to get this going soon. And Tiro for IANA stuff. What advice do you have on the scheduling for getting IANA assignment? There's some reasons we'd like to be able to get just at least a number reserved for this soon, so we don't have to be deploying.
So for
versions.
the early allocations, or because in our expert review, we can actually give it the numbers whenever we want.
So could we do that along with the working group adoption?
I want to make sure that there is not going to be any changes to the format before I gave it. For example, the things that we were saying that, okay, we have this, ordering of the, configuration payload affecting how they're interpreted is something that might actually need discussion. And if we want to solve that differently than having the order, we might want to change the format of the format, and which means that.
So I guess could we kick off the discussion around that in order to just finalize this? Because I believe we think it's in a state where it's good, and we haven't heard any opposition to it yet. So my as an IANA expert, my rule has been that when I think it's stable enough that it's never ever going to change before it out after an RFC, then I think we can get it. Okay.
But I will give numbers, but if it's still something that there's discussions and I think that there might be something happening, then I usually try to wait for that, because I hate to have that we have a number allocated and then we have 2 different versions of the the configuration payload because the draft changed.
Right. So I guess just to that end, if people could take another review over it, because we did get comments last time. We've addressed them. So if there are any problems, please let us know soon rather than let it hang out in limbo.
Valery Smyslov, Elvis Plus. I support early IANA code point allocation because it will help implementers to test interoperability with real values and not to do work twice with private values.
Paul Wouters. Yeah, I would like to actually also get an early code point, because we know that it's going to be these two values, right? We know it's going to be these two payloads, and even if the interpretation of the exact payload will change, we do know that one is the domain name, the other is the key, so that will never change. So I think we should really just get the code points out.
Yeah, actually, yeah, but let's put it this way. I need to check out myself as an expert before I can allocate them. That means that I need to do the review, which I haven't been able to do yet because I've been busy.
So when you have a chance, please do. All right, so we can move on from this one. That's about it there. Okay, so TCP and caps, you just jump ahead. Okay. Is that the first slide?
Yeah.
Okay. Right. So the most recent version that was published had a lot of stuff in reaction to both just the normal reviews, but also from the discussion that we had on the charter discussion, because the TCP encapsulation was brought up a couple times on the charter discussion from the various ADs looking at it. So one item that they asked for was clarifying the issue of falling back from UDP to TCP and how to use this. So we did add some text for that. So it gives a guidance. It's not a must by any means. It's just a kind of a should recommendation here, that you always attempt your UDP first, and then generally you should use TCP after probably one or two IKSA init attempts, and then following whatever timeout scheme the implementation has. So something generally around, like if you normally do 5 sends of the IKSA init over UDP and wait for a response, maybe around 2 or 3 after not hearing back, you would attempt TCP. So that's just a rough guideline there. If that sounds good to people, let me know. If it doesn't, please speak up. Next slide. Right. And so this is just one question I have for everyone. Previously, I had taken the kind of the fallback algorithm out of scope because we mainly wanted to just specify how do you put the IC and ESP frames into a TCP stream. And we had mentioned before having potentially another document that said, here's how we can use it in various use cases, such as the VPN case, such as the case in which we have connections to carrier networks, other ways in which you may want to kind of choose the algorithm for how do I know when to use TCP or not. We could still do this. I'm not sure if people think it's still interesting now that we are putting some more recommendations in the main document. So I don't know if there are any opinions on that. Okay, or you can write to the list as well. Okay, next. Right, so we also added clarification that, again, the point of this is mainly showing how IC and ESP can be encapsulated in a TCP style stream, but it is not really specific to just TCP. That was brought up by some of the ADs of why are you trying to change TCP? It's like, no, we're just talking about how IC fits into this stream. So it meant we added some mention into the document of this framing mechanism can be used for any other future stream schemes. Yoav, you look concerned. Not to call you out.
I mean, you're not specifying IC over SCTP. You're not specifying it over QUIC. You're specifying it only over IC, over TCP. So why mention any other kind of stream?
Well, I mean, I think the other example, which is now shove it into the appendix is how do you put this over a TLS stream? I think the point is we don't want to say that you will need some other, length value format for putting over other streams if you have another encapsulation scheme.
I'm pretty sure that if I ever want to do IKE over SCTP, that I'll need to write another draft and can't say, oh, it's already mentioned in that RFC.
Fair enough. That's fair. But I do think this could be used as a reference, at least from that of the formats for how to do the length value on here and how to differentiate the IKE versus the SP packets. Cool. All right, next. Right, and so then there's also some discussion that we're having about kind of the mappings between IPsec and TCP sessions. That's been going back and forth on the list. We had some more conversations today. Essentially, trying to clarify that there is not a strong relationship between any IKE session and the underlying TCP, that in general, you should probably just have one TCP stream between your endpoints for your one IKE session. But if you have multiple IKE associations there, or if you have multiple TCP connections, there's nothing preventing you from sending the packets across the other side. It is really just a transport to get datagrams from one end to the other.
I think that it's the most questionable part of the draft.
Okay.
Because I think you must specify more precisely what interoperability issues may happen if, for example, one side supports only one-to-one and the peer supports multiple TCP connection to multiple IKE connections. Will there be an interoperability issues?
So I think there are two cases, right? So the TCP connections are opened by the initiator. Okay. So if the initiator only opens up one connection and the server supports multiple TCP connections, then it's not really an issue because you have the degenerate case of just one TCP. I think on the server end, this does mean that unless you really know the clients you're talking to, you probably should accept incoming TCP connections. You can have a limit for how many you want from any particular peer, but it's essentially it's asking for whatever logic you have on the responder side of how to parse IKE packets should not be directly tied into one single TCP connection. That you have a TCP connection that's coming in, it just spits out packets as if they came in on IP or UDP.
So
And then you just process them like you would otherwise.
okay, does it mean that any implementation must support multiple TCP connection mapped to multiple IKE, or it may be more restricted? Well, you need to
Yes.
have a map.
Well, if you
somewhere.
can support receiving multiple TCP connections into your box at all,
Well,
those packets
I understand.
will
but
just get re-injected, and you will not have to. You will not. We don't want people to manage mappings between
okay.
TCP and IKE SAs, but the packets can come in off of multiple.
Well, okay. I think it must be specified in more detail in the draft.
Okay, if you could point to the specific lines you want clarified, that'd be helpful.
Hujun, so just continue the discussion with you.
Name, please.
Hujun. So I think for the receiving side, that's for sure. So we can have multiple TCP connections for a given tunnel.
Yep.
But my point is that on the sending side, on the egress side, system need to understand which TCP session to use for which given peer, right? So let's say we allow multiple TCP connection per tunnel.
Sure.
Then if we say that we just randomly choose one TCP connection for any of our try to say, then why would we need to have multiple TCP connections in the first place?
Right.
So I think the question I want to ask here before we dive into all these technical difficulties, is there any use case for the community? Is there any use case to support multiple TCP connections for a given tunnel? Because I cannot think of any.
Right, and so the reason, I'd have to go back to who exactly made the comment initially, but back in some very early reviews, this point was brought up of why can't we do multiple? And so that's why we added it in. Again, so you're mentioning, so what are things like from the initiator's standpoint? since they are the ones who are opening the connections, if they don't have a use case for using multiple, they will open one. If they do have a use case for opening multiple, let's say they do want to send one child essay over one and one child essay over the other, because they don't want them to necessarily get blocked up. Because let's say I have two child essays, one for one route, one for the other. I have some interpretation on my end of, I use one for like large bulk transfers to this thing that's tunneled in, one for fast things. I don't necessarily want them to have the same TCP aspects.
So in the example just gave, right, you
Yes.
have two child essay. For whatever reason, you choose to use two TCP connection, one for each. Then let's say one TCP session goes down on the initial side.
Yep.
And then initially need to recreate the TCP session.
Yep.
But once the new TCP session is created, how does the responder know, okay, now this new TCP session, I need to only use for, let's say, previous, like, let's say, child essay 2.
Right. Well, and so as it says from the responder's end, when the connection opens, you know which IKSA is
Yeah.
associated with based on the packets that come in, either off of the IKE SPI or the child SPI.
Yeah, so because in draft it said you can either using the update SA address or using keep live to update the responder. But if you only allow, for example, let's say I don't support mobile IKE.
Mhm.
If you only use keep live to update the responder, then the responder will start using all the new TCP connection for all its child SA. That's defeat the purpose of you trying to separate using separate TCP session for different child
Right,
SA.
but I think that if you are using multiple, it's kind of best effort and not a strict guarantee. That's what we're saying. If we don't want multiple, I don't personally on my device have a use case for the multiple. It was brought up because other people asked for it. So I'm just trying to find the simplest way to specify it. Do we want to get?
So my point is that if we don't have a use case, maybe we just keep it simple, just single TCP connection per tunnel.
Sure. What do you think?
Instead of giving and continuing at the same stuff. Actually, yeah, I think it's actually gets very complicated if you have multiple TCP connections, especially if you have multiple IKSAs. Because now if if I have one TCP connection to you and I have 5 IKSAs using the same, TCP connection,
Yes.
and the TCP connection goes down,
Yep.
and it gets up by using, of course, different source ports, and so there's no way the responder to know what IKSAs it corresponds to. And then the initiator needs to know when it gets the TCP connection up, he needs to send mobile update. I think we actually can say that yes, we require mobile support here. We require mobile support here
if you want to
because
go
that's
with
actually some of the things we can actually say that
Sure.
okay. I mean, if you are actually going to change this IP address, this thing moving traffic between the TCP connections, that it makes sense to require mobile. But anyway, so you need to
would you prefer to just see one IKSA per one connection?
No,
And
actually, I was thinking about that. Then we actually need to get, then we are getting multiple, updates on the same IKSA.
Yeah.
And while we are doing that, the other end, if he hasn't, some ESP packets he needs to send, he has no way to send them, or because he doesn't know is this TCP connection for that traffic or something else.
Although I
and
would
he
argue
needs
that's kind of equivalent to today if I'm doing UDP and for some reason the NAT mapping goes down in between us. Even if you are sending ESP packets, they're going nowhere.
Yes,
Like,
that's
so we're already in a case in which something terrible happened to your connection.
Yep.
And
Yeah, that's
otherwise you
true,
wouldn't
that's
have any
true.
connectivity.
Yeah, that's true. And actually, one of the things that you're talking about is we already have this similar kind of thing in for ESP, where we say that okay, if you have multiple ESP connections, multiple child essays
Yes.
between the peers, it's responders or senders, choice how to use them.
Right, exactly.
And
Because they could be overlapping
using same
routes.
thing here, but that's so we can actually leave it to implementations. But
Yes, that's what I was leaning
it's-
towards.
Yeah, but I think it actually needs more, thinking about how to actually solve this issue if you have a multiple, and I think it's okay for us to restrict things unless there is really, some proper use case why we want to do that. Actually, for example, I think in most of the cases, yes, in responder side, we need to support multiple TCP connections because we might not notice that the TCP connection is already down. Initiator knows it. We don't because it hasn't timed out yet. So for our point of view, it's always we get a new TCP connection, so we have two TCP connections.
Right.
One that is broken, but we don't know it, and the other one is up. So,
Yes.
and then we get, updates for that, and then we move traffic to that. So,
Mhm.
so in a responder end, we always have that. But I don't think if there's very much use cases for having, multiple, TCP
Intentional,
connections,
right.
especially for the same IKSA. I would actually say that it would be forbidden, but if you have multiple IKSAs, then of course you can play to be on multiple hosts.
Right.
So then it's no different if you are actually multiple hosts behind the same NAT,
Mhm.
or if you are one host behind the NAT, because if you have. So I think that's something that needs to be
Yeah.
thought about, and I think we can actually restrict it more and
Right. And
limiting it now is making things easier.
yes.
Is worthwhile than
Yes.
just to have everything that we actually want. And actually say, I think we can actually require Mobike here. Because this
Require
is
Mobike for anyone using TCP encapsulation, or just anyone who wants to be able to revive a connection?
Actually, I think because
Because a lot of things don't necessarily have Mobike, so I don't want to tie those two things together. I don't want to tie the entire feature to it.
all right, I don't know, but yeah.
Sure. Yeah, I think that's a good point for the responder side, that even if we're not intentionally using multiple connections, it may often look like multiple connections to a responder. Okay.
Paul Vargas. So we had a similar problem in our code where if the NAT mapping changed on the UDP part, then we noticed the new incoming packet, recognized it was a retransmission, dropped it, and then so we never actually sent them a packet back to the new port. So it's very important actually to, I think with the TCP, is when you set up a new TCP connection as the initiator, you must always send a packet, an IKE packet, over the channel so that the responder will know that this is the new channel for that SA, so you can reply to it. So just don't set up an empty TCP connection,
Right?
because then the responder will also always have the most recent packet, the most recent IKE packet, and knowing where it came from and sending it back over the same channel.
Right.
And so then it can actually just close all the older TCP sessions that apparently are no longer used.
Right.
On the assumption that if the client opened a new one, it determined the old one was dead anyway.
Okay. And so essentially the rule is the responder sends packets back on the connection that it received for the same SPI.
Correct. And then
most recently.
exactly.
And then for child
be
essays?
careful with a retransmit.
Right. And do you think it makes sense to then have all the child essays have to be on the same connection as the IKE SA? Because we don't necessarily send an ESP packet on every.
Right. So I don't understand why different child essays would be on different TCP streams. I see the TCP stream as a parent SA property and not as a child SA property.
Sure.
So I don't understand why they would be split over different essays.
That's fair. That's fair. And you could have potentially multiple parent IKE SAs sharing a connection if you don't want to have too many TCPs. But
Sarah, we need to close the line.
anyway, sorry. Yeah, I don't want to spend too much time. We can also take this.
Sure.
to the list.
I want to push back against what Tara said, that you have to have Mobike. You can bless the new connection with either an ESP packet or an IKE packet or a liveness check if all else fails.
Yes.
And but it has to be a packet that has been verified, decrypted and MAC'd and
Yes.
and okay with replay, because otherwise I can take a single packet, open new TCP connection, and get you to close the old connection and start sending all your ESP packets to me.
Yes. Yes.
So it has to be validated, including with replay protection.
That's a good point. We should add that specification.
So I just want to point out there's a difference between supporting multiple TCP connections for different child SA versus as a responder, let's say your initial TCP session goes down, I create a new TCP session, then you have this old TCP on the response side, you have old TCP has a timeout. These two cases are total different cases.
Okay. So that so you're saying that at any given time,
yeah, that's only
each
one
side
TCP.
will only have one, and
Yeah.
maybe they have two connections, but they migrate from one to the other.
Yes.
Okay, that's fair. That's simpler.
They're giving it. So I think actually it would still make more sense to require Mobike, but because we have the same issue with the not traversal, and the reason there is that yes, we had these rules that when we get the packet in and it has a different source and destination port, we just update our mappings, and it worked somehow, but it wasn't that good. There's some issues with that. We had that's why we actually started doing the Mobike. We actually do this address update. We get the round trip back and actually do this real telling yes, our stuff changed now, and this is the latest one, and we have cookies to do that kind of thing.
Right.
So
I agree that if you do have Mobike, it's better.
Yeah.
Because it's very explicit. However, I think that the TCP case is actually probably a little bit better for migrating your essay implicitly than UDP, because at least you actually have had like a three-way handshake for TCP. So you have a little bit better idea that it's not just some bogus reroute.
Yes, perhaps. If you, unless you guess,
It's not like
unless you
Mobike
guess the sequence number.
I wouldn't mind saying that Mobike is a strong should.
Yeah.
Okay, but I don't want to limit people who don't have Mobike. Anyway, I think that's about it. Yeah, so I guess we'll have more conversation about the multiple essays. I'll update the draft based on that, and then we can try to move forward if everyone's happy. Great, thank you.
Thank you.
And then we have the next two documents that are getting more or less ready, I hope.
Hi, I'm Ravnir. So I'm going to talk about the status of the Edwards DSA draft and the status of the implicit AV draft and next steps for both. So the EDDSA draft is a 0.0 version published on October 28th. There were a couple of individual draft versions before that. Changes, well, we changed the OAD to match the example of a certificate in draft IETF kernel PKEX, and that is now in working last call in kernel. I added the hex representation of the OAD to avoid the need to have a full DER or ASN1 module as part of ICA. That's similar to what we have in RFC 7427. The digital signature draft, RFC. We've prohibited the pre-hashed versions of the Edwards curves, and we need to see what text we need to add to address context. There's a little, there's a couple of slides about that later. Okay, when I prepared this slide deck, the CFRG draft seemed stuck, well, yesterday at the CFRG meeting, they said that it got unstuck and it's in the RFC editor's queue, so it's probably going to become an RFC before either the kernel or the Ipsecme draft. Okay. Okay, so the only really new thing in that the draft defines is the null hash that we need for using the Edwards DSA signatures without pre-hash. So, next slide. Okay, the implicit AV draft is we've published version 01. Removed version 00 had several alternative ways of negotiating the use of implicit AV. And we removed all of them except the one that adds new transforms. We rewrote the IANA considerations accordingly and fixed some references. It's still not a working draft, but it's already been accepted, so it's just a matter of Daniel submitting the document as a 00 draft IETF Ipsecme document. So next. Okay. Edwards DSA context. Now, the Ed 448 added a new parameter that's called context. That's a really neat idea. So if you do use the same private public key pair in two applications, for example, IKE or TLS or certificate signing, an attacker might be able to compromise the signer by having identical plaintext featuring more than one protocol. So if we could get something that is sort of like an ICA in it, signed as if it was a certificate. This is really far-fetched. Then we could have a signing oracle that could give us a valid signature for ICE. Now, the traditional PKI countermeasure for this is don't use the same key for two applications. But people still do. So they invented this new context parameter. It's kind of a string parameter where if you use the same buffer, the same to be signed buffer in two applications, because you have different context, string context, then the signature comes out differently and you don't have a signing oracle. So next slide.
So I'm confused. How could that ever happen when you use it for IPsec? Because you're signing the whole packet information and everything. How could you ever get the same data signed compared to like TLS or PGP or whatever?
What if an IKSA init, that's what you sign in IKE, happened to look exactly like the beginning transcript of a TLS client hello whatever? You can't get it,
But we also sign IP addresses and everything. But that's also
eventually we sign a buffer. If the buffer,
I think he's saying it's
made
not
to be
very
the same.
likely, but somebody might claim it might happen at some point when the moon is right and everything is cloned and you won a lottery 3 times in a row.
I mean, if we were assigning hashes, it would be slightly easier because we only had to get the hashes to collide. With EDDSA, you actually have to get the plaintext to collide, and that's even more difficult than it was when you signed the hashes.
Okay, why don't you just prepend IKv2 to the plain text?
That's what context does, actually. By the way, it's not just ED 448. There's also ED 255.19 CTX, which is a variation of the ED 255.19 with context, except nobody uses it because it's not the one that's implemented in several libraries already. So that's really in.
Have someone from hello. This is on. Yeah, from from Jabber. So there's someone. The answer is that it's a signing oracle, and that is a bad, if not good, thing. Sorry. Context is easy fix. Did you understand what I said? No. The answer is that it's a signing oracle, and that is a bad, if not good, thing.
Well, that assumes at least one of the protocols
I.e.,
is
not
signing
if
protocol.
what?
A signing oracle, because most of these needs
It's not
to
a
have
bad
valid-
thing, I think, is what he said. Sorry.
Michael Richardson, I think the point is that if you build a machine and you put all of your private keys in some HVM or hardware device, that you have offloaded all of your stuff, and that thing could easily be convinced to sign 2 blocks of text that are the same. Okay, I think that's the point, right? And so if you have that thing, that's a good thing that you have offloaded and you can't touch your private keys and all that stuff. That's a good thing. On the other hand, that thing can't protect itself against being screwed this way. So we have to provide some help for it. I think that's the point.
So you are saying that if somebody actually hacks into your machine and then not sending actually the IKE, exchanges of what IKE is actually signing, but actually fake something else that is, and you send that to the hash jammer, then it calculates that. But of course, then it could also lie to be the TLS, to do the TLS handshake. So I don't know, because I think you have to remember half of the things that we are signing is from the responder, or half of it is from the initiator. So it's actually not something that you can, attacker can't, it can only control half of it. So it's not really, very easy to use it for anything, because it's, if you are actually running something in the protocol level, you can't, force, there's a random nonces, there's a random SPI, so there's random things that you can't control at all because they're generated by the other end.
Yeah. So there are really 2 algorithms that support context. That's ED 448 and ED 255.19 context. There's no context in RSA, DSA, ECDSA. If we could go back in time 25 years and tell people add context to these algorithms, then maybe that would be great, but we can't. The CFRG draft warns against using context strings opportunistically. So don't have an IKv2 string that we add where the algorithm supports it and don't do anything with it when the algorithm is not supported. And the reasoning is that if we create our system so that you can use the same key for multiple purposes, then you create all the infrastructure, and then somebody's going to use RSA or ECDSA or regular ED 25519. So unless you're building a system that only supports ED 448, just don't do it. And I don't think we're ready to deprecate all those other algorithms yet. No? Well, not with this draft anyway. So, so what I propose is that we don't do anything with context. We do what everybody else does and pass a null context to ED 448 and totally ignore ED 25519 context. So they're a neat idea, but we just have to decide on text and what to do with them. And I think that we should use a null context. By the way, this same question is coming up this week in Kernel and in TLS. And TLS is like the next session. Okay, so next slide. So we need to decide what to do about contexts, Kernel, also TLS. Then we can go to working with last call, as far as I can see. And we will submit implicit IV as a working group document.
Actually, that's the process. We have to adopt it as a working group document that we are going to be making this. It's in the charter, but the document, the actual document, isn't adopted as a working group. The implicit IV.
Oh, I thought it was.
No, it hasn't.
Oh.
That's one of the things that you're waiting for us to review it, and then let's see that they make it an adoption call, and then it gets it's just a process stuff. It's something that happens there.
Good. And so then the conversation about CCM tag lengths can happen in working with last call. I think that's an open issue with implicit IV, whether we want only GCM with 16-byte tag. Well, GCM obviously only with 16-byte length, but CCM, we want a smaller tag length. And next slide is questions.
Yeah. Question on Jabber. Not clear. Is Ipsecme's decision based upon what kernel does?
We adopt the OID that kernel assigns, and about whether we use contexts. Well, the decision about context is independent. I mean, if we do need, if we do want to use the ED 25519 context, then we'll have to ask for an OID from them. But assuming we decide what I think we're going to decide, then no, we're just. It makes sense that we and TLS and kernel will make the same decision, but it's not necessarily true.
Yeah, that's we had 3 times the same discussions, independent discussions, and we came to the same conclusions.
Well, it's pretty much the conclusion that the CFRG draft says you have to make if you're not going to deprecate every other algorithm.
Okay. So that's everything for that. Then we actually come to the same issue a little bit, because this is about reusing the same private key in different algorithms. And actually a very easy way is to say that no, never ever do that.
Hello, I'm Valery Smyslov, and here is a presentation about some interoperability issues that we met while trying to implement support for RSA PSS with the RFC 7427 in IQ2. So, as you know, in IQ2 there is no negotiation of authentication methods, so each side just use the authentication method that it considers appropriate for the situation. And RFC 7427 adds some ability for each side to announce the hash algorithms that are supported by this side, so that the mutually supported hash can be used in signatures. And at the same time, RFC 7427 adds support for new signature format, RSA signature format, RSA PSS, that is more advanced compared to RSA PXS 1 or 1.5. But at the same time, 7427 has no means for peers to indicate whether they support this format. And whether, well, in general, speaking more generally, there's no indication whether some form of signature is supported or not. And next slide, please. So what do we have? It's a real life example. We have two signature formats for RSA PXS 1, 1.5, it's legacy, and RSA CCA PSS, which is newer and it's considered by cryptography to be more secure because it's has a different kind of padding. And implementation may support both formats, or may support only one. And both implementation will be absolutely compliant with RFC 7427, and they may claim that it's fully supported. But in real life, if one implementation supports only one of these formats, and the IKC setup may fail even if the other side support both, because there's no indication if this format is supported or not. So we came into these issues while trying to make interoperability testing. And I think that not many vendors support 7427 yet, so that's why this issue is pretty new, but it's real. For example, it's possible to add some logic. For example, responder, if responder support both formats, it can use the same format as he, she sees in initiators out payload, and it will work. But for initiator, it is everything is more tricky because it will first, for example, it supports both formats. It try, for example, RSI PSS and receives authentication failed. Authentication failed. It means that either it's really authentication failed or just format is not supported. So what to do? Retry with the legacy format. It will complicate logic. It is possible that initiator would always try with legacy format, but this will slow down adoption of RSI SSA PSS. So it is possible that it has some preconfiguration, but preconfiguration doesn't scale. So there is a real issue. So since PSS is not widely used yet, it's probably the simplest solution for initiator to always use a legacy PXS1. And it's a bad thing because it will slow down adoption of RSA PSS. And next, please. Well, and I think that in future, a similar issue may appear with different signature schemes. For example, ECDSA and EDDSA with Edward Curves. Edward Curves can be converted to short-range truss and used in ECDSA as well. But so if we have Edward Curves key, we can use both signatures. It's strange, but probably it happened. Prehashed or not prehashed forms of EDDSA. Again, the same key can be used in two forms of signatures. Probably some new forms of elliptic curve signatures appear, and even hash-based signatures. We have candidates like XMSS and multi-tree XMSS, and I think that the key will be the same, but signature will be different. Next, please. So what to do in this situation? I think that we have three ways. First way, do nothing. Well, it's a valid option. Why not? We can consider that it is insignificant, Well, and if RFC, well, not RFC, draft 7403bis is adopted, and it states that RSIPSS must be supported, so everyone will support SIPSS, and this issue will go away. Well, so the good thing that there's nothing to do. It's always a good thing. Well, but if similar issue appear again, we will again need to find a solution, and I don't know if it is very simple. And in current situation, we may use some heuristics, but it will complicate implementations, and so there is drawbacks of the nothing. Well, next, please. It's possible to add a quick fix. Just add a fake hash algorithm that will indicate that PSS signature is supported. Well, it just fixes the problem, nothing more. But there are a lot of drawbacks. It's a protocol hack, a clear protocol hack. It fixes only current problem and not general problem. Well, it increases a little bit, like I say, init message size. And again, it needs sometimes to be adopted. Probably at the time it is adopted, the problem, everybody will support ISA-PSS, and the current problem will go. So next, please. And a third solution is to solve a generic problem. For example, it's possible to define a new notifications that will indicate which algorithm formats are supported. For example, as algorithm identifier reads or as some code points. Well, and it will fix problem completely, I think. But there are drawbacks, of course. And it will increase the IKC init message size. That is a bad thing. It will partially overlap with current functionality of RFC 7427. It depends on how it is developed, but partial overlap may happen. And it will reveal some information about PS capability, but it is true for RFC 7427 as well. So that's all. My question, what the community thinks about all of it. Should we start a discussion in email? Should we decide what to do?
So is there an even better solution? Next slide.
No, that's
Okay.
thank you. If you have one, please.
Okay, so Palvartus. So why can't we move this into the IKE auth? Because that exchange is okay to be repeated. So if your IKE auth fails, you can do another IKE auth. So you don't have to actually increase the IKE init message size. It costs you a new round trip, but that's just for legacy clients anyway.
I think it's. I need to think whether it will be work, but again, it's a hack to the protocol, because currently you are not allowed to use different IKE auths with the same SPIs, IKE SPIs. While you fix, well, you need to start over from IKE init.
Yavnir, so the obvious solution is to add a new notification that sends a series of OIDs that we support. That's kind of not nice. Wouldn't a heuristic of using the same algorithm with which the certificate is signed usually cover all the problems?
Well, unfortunately, it may sound so weird, but unfortunately, in situation that we came across, our peer supports RSA-PSS in certificates, but at the same time, it doesn't support an IQT.
Because they have a different library for parsing certificates.
Probably. Well, and again, for initiator, it's not always helpful, because you may not have a responder certificate while you start establishing IKSA. You will get it only
in your own certificate.
Own certificate, but we support.
Well, yeah, but
the problem is that our method can be different.
Well,
I can use RSA-PSS, And the other side can use RSA pixels 1, and it's okay.
Well, yeah, whatever the other side uses, if it can't parse PSS, then and your certificate is signed with PSS, then
Yes,
you're toast anyway.
it will respond with yes, with authentication failed.
When we were writing the signature, the digital signature draft or RFC, we were thinking about this, and one of the things we said that okay, most of the cases the authentication is still left in IKE as a configuration option. You have to configure if you're using pre-shared key. You have to configure I'm using this private key. If you have multiple private keys, you have to somehow be able to pick one of them when you are talking to somebody. So and this is the same issue. If I have five private keys, and I need to talk to some random person, I need to know which one to pick. He probably doesn't support my all 5 private keys. He probably supports only one. So I have to use some method. Usually the method is actually by configuration. You just say that, okay, this private key is used for that, or you have only one private key, which is the most common. Opportunistically, I'm going to try all of them. Yeah, that's true. You can also do that. But I mean, this is no different in that case. So whether you use pre-shared key or certificates, is also one configuration option. You have to configure that. So I think it's most of the cases this issue comes up when you try to make this kind of scenarios where you support everything, but in real life people usually have very tight. They all either use RSA PSS for everything, which means that their CAs used it. Their private keys are for that format. They use only that. In the enterprise, the whole enterprise using that, or they use PKS 1.5 because they have tokens that are or some other things that are using. So I think it's a bit a problem that is not that big issue in real world scenarios, and that the same issue is with the DSA and RSA, which format to use. I haven't heard people complaining that we have this. I have both RSA and DSA keys. I don't know which one to use when I connect to the host.
Well, I see, but I don't know whether such similar problems appear in the future, and lacking an ability to explicitly indicate to the peer what is supported to announce make me a bit uncomfortable.
We're closing the line.
Okay, from Jabber, waiting for will be gone is not right given Ike v1's tenaciousness. So if something hurries up PSS adoption, we should do it. Size of message seems to be a small price to pay.
Okay, thank you.
I lean toward to do nothing, because I think this problem is similar to when you do ICOS, you will negotiate the transform for the IPsec SA. I mean, the other side might not support what you support. I mean, this is the same problem.
It's a bit different problem, because with negotiation you at least get a clear indication that the peer doesn't support it. In this case, you don't have a clear indication. You get authentication failed that may mean a lot of things, from missing certificate to missing authorization in access list.
In that sense, we should define new error notification type, right? That's, for example, wrong key form or something like that.
It's possible to define and authenticate, probably.
Because there's so much in IPsec application, so many configurable things. I mean, we cannot signify everything, right?
But your notification type is not do nothing. It's just a way forward.
So we'll have to take it to the list. Valerie, thanks.
Okay, thank you.
Dave McGrew, you're up with the QR discussion.
Hi, I'm David. I'm here to channel Scott Fluer today, and I'll be talking about the requirements for making Ike v2 secure against quantum computer, the requirements and the updated not yet working group draft. So the background is that Ike v1, when used with pre-shared keys, can be secure against a quantum computer, but Ike v2 does not have this property. And with the resurgence in interest in development of a quantum computer and the potential threat that has for Ike it's important to add security parity for Ike v2 so that we want nobody out there using Ike v1 to be motivated to stay using Ike v1 and not move to Ike v2 because of the fact that the latter protocol wouldn't be secure. So let's see. Nobody has a quantum computer yet. There's a lot of funding, hundreds of millions of dollars around the world being thrown at developing a quantum computer and studying cryptanalytic algorithms based on that. So that's why it's a good idea to think preventively. So the options that you have if you want to make Ike v2 quantum secure would be you could add a new key exchange method like lattice-based key establishment algorithm, which would be hard to do because there's not yet a really strong consensus on exactly which of those algorithms would be adequately secure. And then option 2 would be to add a pre-shared key that's specifically designed to be post-quantum secure into Ike v2. So that's what we've done. That's what we proposed, and now that's what went into the requirements discussion. We call this thing a post-quantum pre-shared key, or PPK. So this is a redundant system in the sense of PPK is used at the same time as your regular authentication mechanism, right? So it's a belt and suspenders approach, and that minimizes the amount of changes to the protocol. And of course, you can use it with whatever mechanism you're currently using. Next slide. So at the previous working group meeting, which was Buenos Aires, is that right? Or was it Berlin? Okay. Let's see. It was agreed to make it a working group action item to add post-quantum security using this approach, but the individual submission draft that Scott put forward was not added as a particular working group item. Instead, it was a requirement that became the working group item. Correct me if I'm wrong.
That's correct.
So, so this made the requirements discussion really important. And there was a poll of the working group, which was conducted entirely independently of the polling for the U.S. election. Okay, so this is a much better poll than that one. Yeah, and so this is great. I think Scott's questions were really good, and we can see, this is an anonymized poll here. We have blue is important, red is nice to have, and green is not important. So simplicity was important to everybody. Preserving Ike security was important to everybody. Protecting Ike traffic against somebody who has a quantum computer was listed as a nice to have in most cases. Identity protection was the one place where there was some disagreement, that one person thought it was important and everybody else said it was either nice to have or not important. And that's because it's a trade-off. You have to trade it off against the other things, especially complexity. And the PPK management, which is one of the challenges, right? So as we move to using a pre-shared key mechanism to get security against quantum computers, it begs the question of how do you actually deploy these? But obviously, it would add a lot of complexity to try to address that. And so it's no surprise that people described it as a nice to have. And let's see, there was, maybe we should move on to the next slide. So I guess I'm repeating myself a little bit here. So the first rule is do no harm, right? We don't want to really change what Ike v2 does and what its security properties are. Simplicity, obviously, you saw was very important goal. And providing all of the security properties that Ike has against an adversary with a quantum computer was not listed as important, right? So if you would have to put the post-quantum pre-shared key, and you would have to decide who else has a PPK and which PPK they share with you, and you would have to do that upfront, and add a lot of complexity with some new round trips if you wanted to provide all the Ike security properties. And you saw in the poll that that's not what people wanted. So, so Scott updated the draft, and I'm going to show you 2 slides. So this one shows the changes between the current draft and the Ike protocol, right? And the next slide will show changes between the current draft and the previous version of Scott's draft. So there's an exchange of notifications on the first encrypted exchange so that you can tell if somebody is never, let's see, there are implementations out there that have no idea what a PPK is, right? So we need to deal with those. The PPK is stirred in when generating the IPsec key material. And of course, this is a major goal, right? We want those keys to be secure in the future. And the major threat that people care about is my traffic is being recorded today, and 5 years from now, 10 years from now, somebody might invent a machine that can actually break the encryption. And lastly, the PPK is stirred in when generating Ike child essays to protect the Ike traffic protected that way. Question?
Sorry, Paul. I'm a little confused what you mean with child Ike traffic.
I can explain that. It's if you do Ike key, then to have because we are using SKD for currenting that traffic will be protected. But the first Ike essay traffic until we do the Ike key is not protected.
The child rekey
Ike key. Yeah, you make Ike essay rekey. When you do the rekey, after that, even if you have a quantum computer, you can't decrypt the traffic in that Ike essay anymore.
So you mean PFS and create child essay? You mix
No,
it with PPK.
we do every time we do Ike essay, we do PFS.
Right.
But anyway, but because we also use the SKD from the previous Ike essay, which contains the PPK, which the attacker doesn't know, so that works.
Okay, from Jabber, since the child essays use KeyMat to generate IPsec keys, and KeyMat has the PPK, then why mix in the PPK again to generate child essays? Did I go too fast?
Yeah, I'm sorry, could you repeat?
Sorry, yeah, I can, yeah, no worries. Since the child essays use KeyMat to generate IPsec keys, and KeyMat has the PPK, then why mix in the PPK again to generate child essays?
So I believe
child essays keys, sorry.
I believe that there's data on the Ike protocol that would be protected that way. And it might be best to take this up. So I'm not sure I can answer any better than that. So maybe we can follow up on the list. So is there another question or comment?
It's just a comment. I asked on the list. You currently redefine key derivation in 2 points for KeyMat and for IKC keying. And did you consider modifying it in 1 point and just redefine SKD, make it SKD a POS that depends on PPK? And since SKD is used for both KeyMat generation and rekeying IKSA generation, it is the single point where everything can be done. So I asked Scott this question on the list, and I think Tara also. support this. Just a comment.
Okay, thank you.
And I think actually Scott already answered that, and I commented to that. But there's ongoing discussion on that list, about that in the list. And
So the good news is on this slide here that this slide summarizes changes between the previous version of Scott's draft and the current version of Scott's draft, and it greatly simplifies the protocol, right? So there's no more negotiation upfront to find out who else shares a PPK with you that tries to protect the identity of the sender. Let's see. So this means that there's less protection, right? But it matches the requirements, and that's actually the next slide, I think. So how do we score against the requirements? So pretty well. The one thing that might be controversial, I guess, would be identity protection. Controversial is the wrong word, right? There was one vote for identity protection. Two said it was nice to have, and then the draft doesn't provide identity protection. It would be impossible to provide identity protection without adding in the complexity that people made clear they really don't want. So let's see, the non-static PPKs and PPK management are not addressed, right? And people didn't, people said it would be nice to have, and of course it would be, but that would, again, add a lot of complexity. So question?
Michael Richardson. I think I'm the one who asked for identity protection.
Which is ironic because you just stated your name.
I stated a name that's on my badge. But have you checked my passport? He has, behind me, yes. But actually, that's, I think, maybe the point. So I thought it was very interesting to realize that the child essays would be protected. And so what I would like to have is an architecture that leads us towards identity protection, even if it doesn't give it to us on the first round. Okay, so that might mean, for instance, that we express pseudonyms on the first round and we bind them on a second round. And I don't know why we're so kind. I get that, site-to-site VPNs, there's not really much point in identity protection, and I think there's a certain amount of the people that really care about this problem are mostly dealing with site-to-site VPNs. Okay, and
yeah,
if the endpoints ain't moving, there's no point in protecting who they are. We all know who the traffic is. If anyone's watching it, they can see it, they can look it up. Okay, I get why the identity protection is irrelevant, but on the mobile side, I think that it's increasingly important, and I think that we saw in TLS 1.3 that's one of the major things that we have that's been added, and I think that up to this point, that's one of the things that IKE has done very well, is protected the identities. At least V2 has done very well, is protected the identity. So I'd like to see that somehow, but I'm okay if it's not in this version, as long as we have some notion of how we would, some kind of this bit in this field is reserved for the identity protection thing. If it's not 0 and you don't understand it, then do something, right? Okay, whether that means fail or try again with it 0, or I don't know but we've figured that out. But I think the other piece of this, and I think that you've hinted at this in your requirements document, okay, is that in the future we may have some quantum key agreement system that's going to feed us the PPK that we want, and that I'm saying, okay, so maybe that's going to also provide us with the identity protection plugin as well. I don't know how it's going to work. I have no idea. All I'm saying is that it's important for me that we plan for that identity protection, even if we have no idea what it's going to be right now.
Got it. So that would be something like a field that we'd say, set the bit to 0, but if it's not 0, then it's reserved for future use.
It's reserved, and we've specified what it means, how we're going to fail or retry based upon that not being 0, right? Because sometimes we fail to do that. Okay, version is, what will we do if it's Ike version says 3? We don't know right now, right? And that's a problem.
Yeah.
Okay.
So so that makes sense, right? The idea of like, hey, here's a field that's got some semantic, like you're describing, associated with that. That makes sense. My hope for the future is that in a couple of years, we'll be here again and talking about this, but we'll have there'll be some key establishment method based on lattice-based cryptography or something like that we feel confident enough to start standardizing as a key establishment method, and then we can just use like v2, just as it is, without having to add in some. I'm going to distribute PPKs using some new thing.
I think it actually is very easy, and we don't actually have to do anything, because what we can do there, we could do so that we actually add new identity type called pseudonym, which is just random object string. And then after we do Ike SA, we do the child SA rekey to get the Ike SA protected for the attackers. And then we do pseudonym, registration protocol, which is, using, for example, configuration set, say, okay, my next pseudonyms are going to be, and here's a list of 5. And the server will take those 5, store them in the file, remove your old pseudonym because it's no longer in use unless it was part of those 5. And the next time you come with one of those 5. So, and it also going to be something random things, and so of course you have to make sure that there's no collisions and so on. But anyway, but it's something that we don't have to actually do anything here. I think it's something that we can add on later as a separate document. And so I think we already are covering with what Michael is saying, especially now when we have this property that yes, we can do Ike SA rekey to get the Ike messages protected. Without that, we couldn't do that. The second stuff is what I talk about is this actually PPK management and non-static PPKs. I agree that we don't want to do anything now for that, but what I would like to have, an option to, to have the information there. So for example, now we have a PPK notify that is empty. I would like to say that, okay, we have PPK notify having some OPEX string in it. Whatever that string is, it identifies the PPK we are going to be using. So if we have 5 PPKs in my server, this will tell you, okay, it might have a number 1 to 5, or it might be random, 64-bit number identifying something using some protocol, or it could be, the CD77 offset 125,000, and that would be, 64 bits of PPK that is going to be used for this. So this is actually something that is completely outside the Ike SA. It's just, okay, this is the information used to find the PPK, and both ends assume that from that PPK notify the identification string of that is completely unique might be unique for the, the ID, or it might be unique for the whole system. I don't know. It doesn't matter. It's implementation details.
Yeah. So you're thinking essentially there would be some string that could be thrown in there. There would be like a hint, right?
Yes.
You don't have to interpret it, but if it helps you, that's great. So I like that. That seems like a good idea to me. The one issue being, there is a table of actions that, like, if you can't find a PPK, you can be configured that you must drop the connection. That'd be the only thing. But I don't think that would actually create a critical problem.
So I'm Debbie Cooley, NSA. So the long-term goal is to not have PPKs, right? So this is just a short-term stopgap. And so that's why identity protection's the secondary concern, because the primary concern is protecting the traffic. So the long-term goal is no PPKs, and therefore you maybe don't have that identity issue. So this is just an interim. This is buying you time.
Sorry, apologies. So just to clarify, Antero, I think indeed if you have multiple sources of getting a PPK. You need to announce which PPK you're going to use anyway, whether it's a one-time pad or your quantum computer that you just bought. So the ID needs to be in there anyway, and the ID can be an ephemeral one that you only use once ever, which maps to the ID, which gives you total secrecy about the ID anyway. So as long as you've got that payload that allows you to tell you something about the PPK you're using, you can get the identity from that securely.
So I think that's the last slide.
Yeah.
Great. So, thanks for the comments and questions. This has been a really super discussion. And I'd love to see this draft taken up as a working group item. I think
That's actually one of the things, because we have started a working group adoption session call for this for some time. You have been taking very long time to discuss, I think about 4 months. But I was thinking about, I think it seems to be now when we have, there wasn't that much people are saying against this draft. So if people are happy with this draft, I would say that we actually take this as a working group draft and then start fixing it, whatever things we have there. But I think it's a good enough phase now that we can actually take it as a working group draft. Last time I wanted to see more of a discussion about the requirements and so on, that we actually understand what we are going to getting. That's why we actually didn't adapt this last time. But now I was thinking about so if anybody has any objections till now, and unless there isn't, I think we are going to be accepting this as a working group, a document after this meeting. I can't see anybody coming up and commenting anything. So I think it's going to be working group document for the next one. All right, so next item is Valerie talking about compact format for IC version 2.
Hello again. Next. Well, there is some motivation for defining a more compact format for IQ2 payloads, and for two main reasons. First of all, there is an IoT world where network communication consumes a lot of power, and for battery powered devices it is very expensive. And even if IC V2 is not used very often, very extensively, I would say, but it still consumes some power, and if we can reduce power consumption, it will be good for IoT world. And second motivation is that once IKSA need messages become larger and larger with adoption more and more extensions and more transforms, it becomes a subject for IP fragmentation, and that is a bad thing for UDP. And it is not protected with IC fragmentation, which only works starting from IC-OS exchange. So next, please. And existing format contain a lot of redundancy. If you look at the dump, for example, of SA payload, you can find that among 48 bytes, 24 are zeros. And it's just encoding contain a lot of 0 bytes, 0 octets. First of all, most IC payloads are short, less than 256 bytes, but payload length occupies 2 bytes, so in most cases 1 byte is 0. Then there are a lot of reserved fields that also 0, and a lot of most IC transforms and attributes are encoded into bytes, while only a handful are defined. So it only leads to a lot of 0. But next, please. So we can set the following requirement for compact encoding. It will be great if it is a generic mechanism for encoding any IC payload, including not yet defined, and so just some specific compression mechanism. And second requirement, that existing format must be converted very easily to compact format, because it allows to plug compact encoding, decoding the current code in current implementation. And for example, you don't need to change IC payload parser, you just need to repack it into regular format and then parse as regular. And it must not increase payload size, it must be simple. Next, please. So the idea is to transmit only non-zero bytes and append a bitmap that will indicate which 0 bytes were emitted from the payload. This idea works very well for any IKE payload generic, independently of payload type. Of course, some payload cannot be compacted if they contain 0 bytes random data. Well, next, please. But there are two payloads that can be encoded more effectively compacted. It's a SA payload and it's notify payload with status type notification, no data. They can benefit a lot from special compact format that will be different from generic, but much more efficient. And it is important because the SA payload is a primary source for IKSA init expansion, and notify payload with status types and no data often used for negotiation and new IKE extensions. And so usually there are some of such payloads in IKSA init, and we can expect that the number will increase while more and more extensions are adopted. Next, please. So for SA payload format, for SA payload compact encoding, we make such changes, such actions: completely remove of all reserve field, remove length field when they are unnecessary, encode all currently defined transform without attributes in 1 byte. It includes both type and transform ID. Encode encryption transforms with key length attribute in 2 bytes, and leave possibility to encode arbitrary transform from private range or from not yet defined attributes. Well, and for example, the current SA payload, it's a real SA payload containing the following transforms that occupies 48 bytes. In compact form, it occupies 11 bytes, more than 4 times smaller. Next, please. So, and for notify payload, there's also a special format that allows it to be encoded into exactly 2 bytes. It's status type notification with no data. Next. And so negotiation is very special because IKSA init message is already encoded in incompatible way with the regular parsers. We need to say from the very beginning that we are using compact encoding. So the new initial exchange is defined, alt IKSA init, that has absolutely the same semantics as IKSA init, except that it has a compact encoded payloads. And so if responder doesn't support compact encoding, it will either reply with invalid syntax or doesn't reply at all. And so initiating may learn from this that respondent doesn't support compact payload. And if it supports, then it replies. And after that, compact format can be used through all IKSA lifetime. Next, please. And so once negotiated, it can be used in subsequent exchanges. Message may contain both compact and uncompacted payloads interchanged, interleaved, and no restriction is imposed. There is rules how to distinguish compact payload from regular payload, and some payloads are just cannot be compacted. For example, if their length is more than 256 bytes, or if they contain random data, that's with such compact method of compacting doesn't work. That payload. Next, please. And So this method is pretty simple. It's about 200 lines of code in C++, both encoding and decoder, and that encodes both special formats for SA95 payloads. It consumes 0 resources, just a few bytes from the stack. It can be implemented as a pre-process or post-process step in message parsing, composing code. Next. So, questions, comments?
Paul Wouters, can you go back 2 slides? The using slide? Yes. So you say you can recognize this generic compact format by seeing non-zero bits in the reserved field.
Yes.
But what if we end up using a bit in the reserved field for something else, which is why they're now reserved?
If it happens, then this compact format cannot be used, of course, but this compact format uses only 3 bits from reserved field. For you have 5 bits, 3 bits, 4 bits.
Right. So you're reducing the reserved bytes from 5 to 3.
Yes.
So you're using them basically.
Yes. But currently it isn't used. And can you envision that it is used in near future?
People might say you're greedy taking more than 1 reserved bit for a new compact field. But anyway,
well, if people are so greedy, the kind of format can be redefined, make it a bit less efficient, and consume a single bit from that field. Is it okay?
I think that would be better, yes.
Okay.
But anyway, what I fear is that some of these IoT devices will actually only implement this and not be able to deal with the non-compact format. And then we're going to have massive interoperability problems.
It's probably, well, if they implement only compact format, they will, I think they must communicate with dedicated servers that also support it.
Okay. I had one other point.
And you can also go back to regular formats if server doesn't respond. So there is some kind of negotiation, some kind. So, and as I said, the complexity is pretty low. So even IoT devices may afford both format, but compact format is more efficient.
So I'm not entirely sure. If I think about our implementation packet parser generator, I'm not sure if this is 200 lines of code. I think it might be a bit more, but Michael can say more about that. I also think the case of where you worry about the Ike init becoming too big, I think that's just a generic thing. And
yes.
if we ever have a solution for that, I would think that should be completely separate from this draft.
Yeah, I think we have been having the reserved fields for 90 something, and we have used 1 bit there, the critical bit, and we are not using that either. So I think using 3 of them there doesn't really matter. So we can, if we can get the 3 and get the very good compression, that's actually very good trade-off for those bits.
Okay. That's what I think.
I'm not sure if the question there is that if people are really going to be using this is the next question. Is this, yes, there is they do in these IoT devices, they do whatever tricks to get, single bit out from the, packet, and they do all kind of weird things. Like we had, I don't know if people were in LP, we had WRN like yesterday, and they were doing all kind of weird, okay, we have rules and we got these kind of things. And so actually I was thinking about we might actually get even more compression if we just, do that kind of things. But the question is it actually useful to have, this kind of intermediate compression, or should we have, really as good as I think in most of the cases we can actually, in IoT devices, we can reduce SA payload to 1 byte. And that includes the SA payload, number, because it has only one. It's ASCCM with, it has fixed parameters and nothing else.
Completely different format, and this is just
completely different. Yeah, that's actually a question I would say. Okay, is it worthwhile to go halfway, or do we actually want to go as small as possible? That's the discussion.
Yes, but advantage of such approach is that all the flexibility of current format is preserved. And as I said, for SA payload, you can encode all currently defined values, all. And there is a room for about the same number of new values. And even for private values can be encoded in slightly less efficient. So all the flexibility is preserved. And just one remark for Terra. As you know, 8 or 5.4 IoT, it uses, it internally fragments in 128 bytes blocks. So as far as I understand, if your, like I say, need happen to be 130 bytes, you will occupy 2 full 127 bytes. So few bytes may appear to be 100 bytes.
Actually, you use 11 plus 3 bytes extra for the, or depending on the addressing mode for the extra headers for the fragmentation. But it's not that big. It's what the most issue is there is that especially if you're doing things like a TSCH, then you have to wait for each fragment needs to wait for a next transmission period, which might be 1 second late. 1 second later, it might be this next time you send the packet now. 1 second later, you can send the next fragment. 1 second later, you get the next fragment, and that's why it gets very slow. But yes, but in there, actually having the compress it very as small as possible would be the best.
Tommy Polly. So, I mean, first off, the goal of compressing, I think that's great for IoT devices. I am worried with the complexity here, as you mentioned. It's maybe implementation is not too hard to do, but it seems to add a lot of complexity to the protocol. I like Tiro's approach. I think, so practically speaking right now, if you want a small packet, you just don't put a lot of transforms. Like if you're an IoT device, you can already reduce your notify payloads and your SA payloads by not putting too much in there. Because if you know what you need, you're done. And those are all already pretty small. We're not going to be at hundreds of bytes then. And if we do need more flexibility, I think it'd be interesting to look at ways we can have alternate payload versions, like you're saying, like here's a profile for an SA, rather than necessarily complicating how I need to encode a payload by doing these here are the 0 octets in this. Just have a new format, have just like a compressed format that doesn't require parsing and unparsing from the expanded format into the compressed format. Just have a more compressed payload. Yes. And let's look at ways we can do that, and then let an IoT device replace the current payloads with those other alternate payloads if they need to.
Yes, it's a way, but then we should redefine all the payloads.
Sure, I think the overall work of let's have more compact IK is an interesting area, but I think I'd rather look down that road than through this.
This scheme is a compromise because it completely redefines 2 payloads, SA and notify, and one kind of notify. And for other payloads, and just define a mechanism to compact them, not very efficient, but a single mechanism. So it's some compromise.
Michael Richardson, still. So I think that you need to compare your work to what would be the effect of running the generalized header compression on it, which generally does quite a good job of removing zeros. And that's not all it can do. It also can do, you can build it up to building probably pretty close to LZH.
Lines are closed.
Pardon me?
I was saying to.
Oh, okay. So I think it's worth comparing it to that for the simple reason that the IoT device, if it's already using GHC, which is mostly at this point we're not, but we'd like to, may already have that code. So that's a code advantage there. Second thing is I understand what you're doing, and I haven't read your draft, so I'm only going your slides and what you said. This is between, so this would be done compressed prior to encrypting, but after authenticating in the case of we're doing it, running an auth over it. So is that correct? No?
No. Because you have encryption and authentication when you process encrypted payload. And
So,
that is
so
just
we're
a
going to, we're going to authenticate the compressed data there. So when it comes to stuff that goes into the auth payload that we're going to assign,
yes,
it's going to be the uncompressed thing, but that we're going to now authenticate it in the IKE essay with this. So essentially, one way to signal this then is to say I'm using this compressed auth encrypt method rather than AES or AED. Okay, I think that's one thing to consider.
Okay.
Okay, because I think that it's happening opaquely below at the encrypt authenticate layer. Right? Does that am I wrong in understanding it?
Well,
okay. So so I think that's an important thing to think of, and I think that makes it relatively easy, because if it looks like this, you know, encryption algorithm that sometimes makes things smaller, which is going to make some complexity for some people, because I know my implementation expects the encrypted result to be the same size as the unencrypted result, but I think I can solve that. Again, as to the question is this going to be useful? Okay, well, maybe. I watched Danielle, who's in the back, you know, do a lot of work on Diet ESP, and I also asked, is that going to be useful? I'm an Ipsec bigot. I really like it, and I don't see it being used in this environment. And I'd like it to be used. I don't see it being used. I don't think it's going to happen. I think this is great work, but I don't think it's worth spending our time on right now. If we need to do it in 5 years, I think we can do it in 5 years. Someone will read your document, implement it, and show how they saved, you know, 30 billion joules in their traffic light system, right? Whatever.
Okay. Okay.
Can we make this last one a short one?
Yeah. Brian Wise, Cisco. So I think if this is for IoT devices, it'd be great to see an IPv2, if you will, for IoT. But I think, sort of echoing what other people have said, those devices want to reduce the code size as well as reduce the bandwidth that they're sending. And so that will definitely lead to some of the interoperability problems I think that we're hearing about, where they're obviously then not going to implement other exchanges and such to reduce that code size. And so I think there's a fairly major job that has to be done. And for this, we might as well just go the full, see what we can do for a full compression, like Cheryl suggested, I would think. And again, if we're not doing this right away, as Michael suggested, then we'd have time to think about that.
Your name?
Brian Wise, Cisco. I said it too fast.
Yes. Okay. So we are coming back to this on the list, I think, and we are actually. I would like to, people to talk about this in the list, and of course, then this is not in our charter, so we are going to be doing something on that. We have to add it to the charter. But anyway, so I think it was interesting, and we had some discussion here, so people were having some kind of interest, at least to say something about it. Okay. Next presentation is then.
While we're doing that, anyone need a blue sheet?
Hello, everyone. It's Frank Xia, Huawei. Okay, this is the 0.0 version, a new draft for the working group, and it's also our first presentation in IETF. Okay, and lastly, this is a very simple proposal for specific scenarios. So I hope that everyone will listen to it very happily. Okay. This draft talking about the encapsulating ESP packet in the UDP. So next slide. So what's our motivation? We know that currently IPsec VPN is widely used for some enterprise customer to interconnect their different distributed branch among over the IP WAN network. So how to effectively utilize the network bandwidth. So I think that's interesting thing that operator or the enterprise customer will always be interested. So we usually use the ECMP or lag to implement it. So okay, we have this requirement. So how to support it? So firstly, we don't want to change anything to the IPsec protocol and the packet. So to reach this goal and avoid any change to IPsec, we propose a very simple encapsulation method. Is that we encapsulate the IPsec ESP packet over the UDP packet. And by this way, we can use UDP source port as an entropy field for the load balancing objective. So that's a very simple proposal. Okay, next. Okay, we can see that this is our ESP in UDP encapsulation format. So like what I said, the source port is used as an entropy field. So so how to calculate this entropy field is a device internal implementation, and we will not discuss in our draft. A special case is that if you don't want to use this use this field as an entropy, you should set it as a random selected constant value for to avoid the packet reordering. So that's a point need to be careful. And then we use a destination port to identify. Okay, this is the payload of the UDP is IPsec ESP packet. So this value need to be defined, and then the UDP length and the UDP checksum is just the similar like the original definition of a UDP packet, and the payload is a ESP packet. Okay, next page. So okay, next page. Okay. One thing that we want to clarify is that there are already another IFC 3948, which describes another use case of encapsulate IPsec in UDP for another goal, which is for the net traverser. So the difference between that solution and us is that they use the source port as a constant value to indicate that this packet needs to support the net traverser, but we use source port as an entropy field for the network load balancing. So that's the difference. So anyway, in summary, this is a very simple proposal, just the encapsulation of IPsec packet. Okay, that's all. Any comments?
Yes, from Jabber. SPI already identifies a flow. No need for any other field or flow identification. Any LB decision made by the destination must be transparent to the source.
We will take the remote queue now.
Okay.
Let's see.
Paul Vartus. Oh, sorry. Scott.
Yes, okay, am I on? Yeah. Okay, I have a quick question. As you'd already noted that there already is a ESP encoded in UDP format. Why don't you come closer to reusing that? You said that you might need the source port to be something other than 4500. Don't follow that exactly, but again, I don't know much about load balancing. But if that's the case, why don't you preserve the rest of the format?
Preserve the origin. Yeah, I think we don't make any change to the IPsec packet and the protocol, just to use encapsulation method to use that UDP source field. Source port field for the load balancing.
I think his comment was that because the UDP encapsulates the destination port is fixed to 4,500, the source port is actually fixed. It said that when you are sending it, you are using 4,500, but of course NAT will change it. So for the recipient end, it doesn't actually matter. So he was asking, why don't you use that directly? So why do you want to allocate a new destination port? I think that was his question.
Yeah, Lorenzo Colletti, for don't do this in IPv6. For v4 only, you can do this. In IPv6, just use the flow label. It gives you more bits. And they're already there. So there's 20 bits in there that you can use, and there's an RFC for that. So
Yeah, maybe there
Lorenzo?
are several ways can achieve same goal. I think we just propose the optional way.
Hi, my name is Uma, last name Chanduri, Uma Chanduri. So I have another use case. It's a very good thing. Actually, we have been discussing earlier, like few months back in my old company, for mobile backhaul, where you want to get the security packet like from eNode B cell site router to the all the way to the packet core. If IPsec packets are there, then we have cases where policy-based routing has to be happen without IPsec actually. So we will have trouble with IPsec, how to do PBR at the cell site router. So this is a very good solution for that.
In IPsec packet, we also already have a flow library. It's called SPI. And SPI can be actually allocated by the sender to be suitable for whatever he wants to put in the load balancing case or something like that. So and that's 32 bits. So sender can use that. I think it would be better to use that than actually to have a separate 16-bit number in the port number that is allocated somehow, but it's not necessarily tied to actually to be useful. It needs to be tied to the IPsec, and in IPsec actually we have the SPI that starts out that already.
Okay, okay.
We
will see that.
I think SPA will not be. That's okay. SPA will not be sufficient. Like in some cases where you want to identify the flow with a port actually. So then after encryption, after ESP, then you have to use this extra UDP.
Tommy Polly, right. I would again say it still feels like the SPI should be sufficient. Also, when you do have a NAT, how exactly would this work? Because so today you create essentially the hole through the NAT with the IKE traffic, and that is the entire point of doing that traversal. If you're now changing what local port you're using, the others right. So I guess when the other side wants to send something back to you, I guess. So when you send packets one way, you just choose a random port. When the other side sends packets back to you, do they also choose a random port? Or is this a one-way thing? What port do they send back to?
Currently, we do not consider so much, but I think in current situation, it should be different. No relation among the two directions.
And so will this work through a NAT?
We assume that there's no NAT.
Okay, so this is
just
specifically
IP VPN.
This only works for devices
IPsec
with
VPN.
non-NATs.
It's an IPsec VPN. Sometimes I don't think we need the NAT.
There's not always NAT,
another.
There's very often a NAT.
We have to take this to the list and move on. So next we have GDOI group key push acknowledgement message. That's a mouthful.
That's why you say it.
Hi, my name is Umesh Mangla. I'm going to talk about GDOI group key push acknowledgement message. So this is a joint work. Brian Weiss is the lead author of this draft, and Nilesh Maheshwari and Thomas Carl are the co-authors. Is it better?
Yes.
Okay, next please. Yeah, so to give some background, GDOI, you all know it was done as part of AMSEC working group, and it uses IKE1. And GDOI, I think all of us know, it's a group key management method by which a group server distributes the security association to all the members in the group. In the GDOI RFC, rekey is described as part of the group key push message. And group key push message is also used by server to alert all the group members whenever there is a change in the policy, that's including the key material. But GDOI RFC doesn't provide the acknowledgement of the group key push message. That's where this draft comes into picture. Next, please. So problem statement is coming from a real world deployment scenario. Interoperability among different vendors. If there are two vendors, one providing the group key server, another group member, so they don't interoperate. So group server may end up removing the group members, which group members which are not able to send the acknowledgement back for when receiving the group key message. So it is preferable if the server receive these acknowledgement messages from group members, so that server knows that group members have acted on the rekey message and the policy contained therein. So this draft addresses this aspect. Proposed solution is basically to introduce a method by which group member returns the acknowledgement message to the server. So how initially server requests group member to acknowledge the group key push message as part of the distributed group policy, and group server delivers the push message, and each member who honors this group key server request returns with the acknowledgement message. This message is optional. Next, please. So this is basically a picture describing the same thing which we talked about. Group server sending the group key push messages, and the members returning with the group key push acknowledgement. Next, please. So here's the message format. So server sending the push message. This is an existing message in the GDI RFC, and group key push acknowledgement message is the new one which this draft proposes. Next. So it describes group member operations a bit in detail. So member receives the SA key payload as part of the group key pull exchange or as part of the group key push message. So this payload contains KEK ACK requested attribute, and when it receives this message, member updates the group state so that it knows that it has to return with the acknowledgement message whenever the push message comes. Group key push ACK message is sent if the push message contains the delete payload as well. Server operations, basically, it starts with the policy, server policy, which specifies that it needs to request acknowledgement from the group members. And once this policy is there, server includes ACK requested attribute as part of the KEK payload. And it includes every time whenever the KEK payload is delivered, both as part of pull exchange and the push message. When server receives the acknowledgement message, it verifies its group policy, it validates the message, and acts for that particular group member. Next, please. So next steps. So this draft basically describes a deployed solution currently implemented by multiple vendors. So basically looking for the feedback from the group. And given that it is augmenting GDI, which was done as part of MSEC group, so is Ipsecme appropriate or enthusiastic about it? And so far, tentative plan is for the area director sponsoring like other GDI work. That's all.
So we have very little time, but we can take a couple of comments.
Valery Smyslov, I have doubts that this mechanism is reliable because ACK messages can be lost. So if GCKS doesn't receive ACK message from some particular GM, it means nothing. It means nothing because it means either that GM is switched off or some crashed or just ACK message is lost. So to be sure, it must transmit push, and how many times? It leads to amplification attack because you will get ACK messages from all the other GMs as reaction of single multicast. So I think it is not reliable and probably a bit dangerous in some situations. Thank you.
So Kathleen Moriarty, AD, I would love to see feedback on the list. So if you could maybe reiterate that back on the list, and we could see a longer discussion. And I'm sorry, I have to get out of the room at the moment. So because we're at the end. So I would like to see feedback in any case. Thanks.
Thank you.
All right. So I think we are going to take this to the list, and we're actually probably going to be discussing this in the IPsec list. I don't think the MSec list is it still there, or is it? Is there an MSec list still? Okay, so we can actually put the CC on both lists and discuss this. But I mean, I don't know if we are going to be taking here, but we will be discussing about this. Okay. I think that's all for this week.
Thank you.
Hey.
That's a pretty full agenda too.
Yeah, we suddenly had a full agenda. We asked for 1.5 hours.
Yeah, we were concerned though.